If you noticed, it says section 3.1. We just finished chapter 1, so we're skipping chapter 2. All right. It's not that it's not that important, but we can't hit every chapter in this. We can't hit every chapter in this book, so I got to pick and choose what I think is a little bit more important. So I decided to go to chapter 3. Okay, that's really the only reason. So here's a word that we're gonna. Whoops, I got to change something here. Change that. Change this. Okay. All right, now it's time to pay attention. Let's follow what's going on. This word you've probably we might have even used a couple times this year. We haven't used it officially, but you've probably heard about this word before. Okay, it's parallel. We're talking about parallel lines. But we're going to throw another word in here. We've got parallel lines, and we have a thing called a transversal. I'm sure you've probably heard of parallel lines before. You might have not heard about transversals, but that's what we're going to talk about today. So let's draw a couple lines right here. And a lot of lines. It's not all it is, but much of geometry is made up of lines. Not all of it, but a lot of it. So let's put an arrow here and here. Take Algebra 2 next year. Alright, so here's two lines right here. They got arrows on both ends. Right now you probably know something about parallel lines already. I mean, when you think of parallel lines, somebody talk to me about what they think. They don't intersect. That's good. What's that? They don't touch, right. They don't touch each other. They don't intersect each other. Okay, they'll never cross each other, right? But there's more to parallel lines than just not touching each other, because there's another type of lines that don't touch each other, but they're not parallel lines. We'll talk about that in a few minutes. Okay, but parallel lines must have two things must be true about parallel lines. Okay, first of all, they don't touch or they don't intersect. So we'll say they do not intersect. Alright, so they don't intersect each other. So these two lines right here, if they kept on going forever, which the arrows on the outside indicate they keep on going, it doesn't look like they're going to touch each other, does it? Alright, but we can't just always go by that. But they do not intersect each other, so they'll never intersect. That's one thing that must be true about parallel lines. It's not the only thing. Here's another thing that you probably didn't learn when you were a kid. Probably, I don't know, 5th, 6th grade, you might have learned about parallel lines. They probably just told you back in 5th or 6th grade, whenever you first learned this, is that they're two lines that never touch each other, that don't intersect each other. They may have even used the word intersect, I'm not sure. But that's probably, they ended it right there. But another thing that must be true about it is they must lie in the same plane. Lie in the same plane. That's pretty important for parallel lines. Now, we've talked about what planes are and all that kind of stuff before, and I'll show you a little example here in just a minute. All right, so they don't intersect each other, and they lie in the same plane. So if these two lines will never intersect each other, then they're going to be parallel lines. Let me show you how they show you on the picture if they're parallel lines or not. All right, so I'll just show it to you. If you put an arrow here and here, I made it a little bit bigger than these. I even made it a different color. Sometimes in the book they'll do that. They'll make them a different color. Sometimes in the book they'll actually make them like a solid arrow. They'll kind of shade it in like this. I'm not going to do that, but in the book they could do it like that. But if you have an arrow somewhere in between, doesn't have to be like right in the middle or anything like that, but if you have an arrow here and an arrow here facing the same way, just by looking at your picture and just by looking at those two arrows, that tells you that these two lines are parallel to each other. All right, so if I see two lines like this, and I see an arrow somewhere in the middle and another arrow somewhere in the middle, just like this, that tells you that those two lines are parallel. So if they're parallel, it means they're never going to touch each other. They're never going to intersect, right? But they also lie in the same plane. So that's what those two little arrows right there indicate. If you look on the page 171, there's a little box, and you'll see a couple lines, and you'll see like a red arrow right in the middle, like this. That indicates that those two lines are parallel to each other. All right, let's name these two lines. Let's name it L and M. They like to use L and M a lot in the book for names of lines, so we'll use those. If I wanted to write it down, if I wanted to say that line L was parallel to line M, well, line L, all I got to do is put that little lowercase l. That means line L. All right. Now, if I said it's parallel to, they give you a little symbol. We've had symbols for all kinds of stuff, haven't we? We've had symbols for lines, for line segments, for rays, for what's another symbol we've had? Angles, right? You've had symbols for a lot of stuff. We're going to learn a lot more symbols as time goes on. But here's a symbol. We learned symbol for perpendicular, didn't we? Remember that? We had two lines that are perpendicular. They formed a right angle. We learned the perpendicular. What was the perpendicular symbol? Do you remember? It was like an upside down T. That's a good way to look at it. All right, right there. That's the sign for, or the symbol for perpendicular. Well, these aren't perpendicular to each other, are they? Because perpendicular, they would intersect. All right, but the line or the symbol for parallel is just two straight up and down lines, just like that. All right, so that symbol right there means parallel. All right, so it's just two straight up and down lines. So if I said line L is what? What does that mean? Parallel to line M. Right, so those two lines are parallel to each other. Now, if I didn't have that red arrow, oops, and this red arrow right here, if I didn't have those two, and all I had were the two lines, could I just look at it and just assume that they're parallel to each other? Could I just look at it and say, well, they look like they're parallel. They look like they're not going to touch, so they're parallel. Can I do that? No, I can't. Okay, I can't just look at them and just guess that they're parallel, because this could just be slightly off. Watch, I could even do this. Watch. Just, okay, do you see how I moved it just a little bit? I moved it, I tilted it just a little bit, but to your eye, it still looks like they're parallel, doesn't it? But it might be off just slightly. This might just be slightly off, so you don't know just by looking at it that they're parallel. But if they told you, let's go to the red again, if they put the little arrow there, what does that little arrow indicate about those two lines? That they're parallel. So that tells you, if they put the arrows there, that means they're parallel. What if they didn't have the arrows there, but they did have this? Then they're still parallel, aren't they? Because they're telling you in a couple different ways that the two lines are parallel. They could tell you this way, or they could tell you by putting the arrows, or they could tell you both ways. All right? Does that make sense? All right, so make sure we get this stuff early, because you don't want to lose out on this stuff now and then later on say, I didn't know they were parallel to each other. Well, you know they're parallel to each other because you got the arrows there, or you've got this thing right here. If they tell you that L is parallel to M, then you know they're parallel to each other. Make sense? That's pretty easy, isn't it? All right. Remember I said there's another type of lines where they don't intersect but they're not parallel? Let's talk about that. Let's see if I still have this saved. I don't. Let's go to this. I had this, I found this earlier. I just got this online. And now I can copy it. There we go. Look at this right here. Let's see if we can find some parallel lines here, and let's see if we can find some of the other lines that I'm going to talk about here in a sec. We'll call that line, let's label all the points, A, B, C, D. We'll call this E down here, F, G, and H. Okay with that? Now, it's a box, all right? They're right angles. It's a rectangular prism is basically what it is. All right, so they're all right angles. Tell me something, if it's a box, if it's a rectangular prism, what might be true about DA and, let's say, CB? What do you think is true about these two right here? They're parallel to each other, right? Because if it's a right angle, they're going to be parallel to each other. So I could put a little arrow here and here, couldn't I? Everybody see that? So they're parallel to each other. What about HE and DA? Look at that. This goes straight up and down, doesn't it? What does HE do? It goes straight up and down. I tell you what, before we get to that, let's look at this. If these are parallel, they must do what? Must not intersect, but they also must do what? Lie in what? The same plane. Do they lie in the same plane? Look at the plane. Yeah, the plane is which one? This DCBA, right? Do you see it? See, it's kind of like the front of the box if you're looking at it this direction. Everybody see that? See that box right there? So that's the front of the box. Does DA and CB, or do DA and CB lie on the same surface, on the same plane? Yeah, they do. They lie on the same plane, and they're not going to intersect each other. What about DA and DC? Are DA and DC parallel to each other? No, they're not. Okay, they lie on the same plane, but they do what? They intersect, right, because they both share D. So I know right off the bat that DA and DC aren't going to be parallel because they intersect each other. There's no way, even though they lie on the same plane. Right? Let's go to this. What about HE and DA? Are they parallel? Yeah. But they don't lie on this plane in the front. They lie on this side plane. Do you see it? But they do lie on the same plane. Would you agree? All right, they lie on the same plane. They lie on that left side of that box, if you want to think of it that way. So HE and DA, they would be parallel to each other. Good. What about HE and GF? Do they lie in the same plane? Yeah, which plane? Just describe it. The back one. Good, because this is the front, this is the left side. We'll call this the back one. Yeah, HE and GF lie on the back plane, don't they? And will they intersect each other? No, because they go straight up and down, so they would be parallel to each other. Everybody see that? What about, let's do a different color here. Got to stay dark because we're writing on the white. What about HG and DC? I'm going to put 2 arrows. Now watch. All the ones with the 1 arrow, they're all parallel to each other. See that? Now, the ones with the 2 arrows, guess what? They're going to be parallel to each other, but not parallel to the ones with the 1 arrow. Everybody see that? So the ones with 2 are parallel, and the ones with 1 are parallel. So HG and DC, are they parallel to each other? Yeah, they are, because they're not going to intersect. Do they lie on the same plane? They do. They lie on that top plane. Very good. Everybody see that? So they lie on the same plane, which is that top one, and they don't intersect each other. What about HG and CB? Look at that. Now, this is a little different, so I hope you're watching. Freddie, you with me? Do you need to sit up closer? Is that going to help you out?
Right here. Come on, Freddie.
I thought you weren't going to be able to sit in that seat. You look pretty comfortable in it right now. All right, so sit up straight, please. Get your feet on the floor. Both feet on the floor, please. Thank you very much. Because you're going to tell me that you don't know stuff, and this is why, because you're not paying attention. No, you're going to learn it now. Okay? It's not about doing it later. It's about paying attention now. It's just respect for me. So look at it. It's HG and CB. I'm looking at those 2 right there. First of all, are they parallel to each other? Well, they don't intersect. They're not going to intersect, are they? Look, this line keeps on going in this direction, doesn't it? Look at CB. It keeps going straight up. Are they going to intersect? You sure they're going to intersect?
They're not going to intersect.
On the picture, it looks, I could kind of see why you might think they intersect each other. Let's do this. Watch. If I took this and extended it and make it a little bit thicker. Okay, so that's extended, right? And if I took this and extended it, it looks like they are intersecting each other, but really, they're really not, because they're on different planes, aren't they? All right. For instance, it looks like they touch each other right there, but this is 2-dimensional, isn't it? You have to think beyond the 2 dimensions. Let's think 3-dimensional. I got a box up here. Let's just take a look at the box real quick. Right, they're on different planes. Look at HG. HG is on a different plane than this one right here. So let's just, let me get a box. We'll look at it. I'll pause the recording here. So we went through the box example, and you see, when we looked at the box, these really don't touch each other, do they? All right, so this one right here goes across this way, this comes, and they don't really hit each other. They might look like they do on this picture, but in reality they don't when you take in the 3 dimensions. All right, so if you have 2 lines that don't intersect each other, but lie on different planes, and they do lie on different planes, what do we call those lines? Skew. S-K-E-W. It's a weird word, but it's skew lines. And what do skew lines do? First of all, they don't intersect, right? So let's write that down. So they do not intersect. That kind of looks like parallel, doesn't it? But there's two things. There's not just one. Say it. Right, they do not, okay, lie on the same plane. Lie on the same plane. All right? So they don't intersect. So that they do have something in common with parallel lines. All right, but they don't lie on the same plane, which means that they are skew lines. Everybody got that? Now we're going to deal with parallel much more than we're going to deal with skew lines. We're hardly ever going to talk about skew lines. Yes? Josh Morse. All right, so we're going to talk about parallel lines way more than we're going to talk about skew lines. All right, so, but I just wanted to make sure that we mentioned that and saw what was going on. All right, let's see what I want to do now. Let's do this. Got a few minutes here. We may not finish all these. I didn't finish it in my last class because the seating chart and the homework and all that kind of stuff, but let's do this.
You got homework.
The homework that I went over. All right, let's do this. Here's two lines. What was the name of this lesson? It was parallel lines, then it was something else. And what? Transversals. Okay, I haven't even mentioned what a transversal is yet, have I? But here's what a transversal is. So here are two lines. Let me extend this a little bit more. Okay. Here's two lines. The two white ones are the two lines. And well, there's three lines altogether. But look at the red one. Look what the red one does. The red one intersects both of these white lines right here, don't they? All right. So we call that the transversal. So this line right here is called the transversal. Transversal. So when you transverse something, I don't know, you may not have used this word before in your everyday language, but if you read a little bit, people talk about they transverse something. When you transverse, you go across. Okay, it's what it means. It's going across. So transversal, this does what? It goes across these two lines, or it intersects these two lines. That's why we call it a transversal. That's a word that's going to be pretty important. We're going to use quite a bit. Now let me throw some angles in here, and let's just describe some of these angles. And I'm going to number them, or I'm going to name them by numbers. Make it kind of easy. All right. So here's angles 1, 2, 3, and 4. You guys writing this down? Okay. Justin, you writing it down? You got nothing on your paper? Okay. Joe, you writing this down? Okay. Let's do this. 1, 2, 3, 4, what? We call this 5, 6, 7, 8. I said Justin, I'm sorry, Brandon. Same last name, but I was wondering why you gave me a weird look. I was thinking, what did I say? Called him by the wrong name. So watch, 1, 2, 3, 4, 5, 6, 7, 8. I want you to look at these angles. Do you see how this looks like a clump of 4 angles up here? And it kind of looks like the same clump of 4 angles down here, kind of. All right? So I want you to think about that. Look at angle 1. What angle down here is basically in the same spot as angle 1 is up here? 5 is. Because this, I look at this as maybe about like being in the top left-hand corner of these 4. Would you agree? So 1 and 5, so they kind of go together, don't they? What about 2? What's in the same spot down here with 2? 6 is. What about 3? 7. What about 4? 8. You see that? Well, we give a name for the relationship between these angles. They all have relationships, and we call these things corresponding angles. Now, these are words that you need to know. All right? I'm going to give you a question on a quiz and a test, homeworks, where I'm going to give you some angles, and I'm going to say, list the corresponding angles. And you have to list which ones are corresponding angles. And that's not that hard. Corresponding means the ones that go together, the ones that match up with each other. So look at angle 1. What do we say matches up with angle 1 down here? Angle 5, right. So angle 1 and angle 5, I'll just put a comma. Angle 1 and angle 5 would be called corresponding angles. Everybody see that? So give me some other ones. Angle 2 and what else? Angle 6. Let's just list them. You should be able to list them. Then angle 3 corresponds with angle 7. And then angle 4 corresponds with angle what? 8. So those kind of squished it in there right there. Those are my corresponding angles. You need to know which ones are corresponding angles because we're going to have like 3 or 4 different relationships, different words. This is the first one. First out of about 4 of them. Everybody understand that? So this is the first of about 4 that you're going to have to know. So corresponding angles are the ones that match up with each other. Whatever you need to write in your notes to make sure that you understand which ones go with what, that's what you need to do. All right? So 1 and 5 go together, 2 and 6, 3 and 7, 4 and 8. Now I could have listed these differently. Don't just memorize 1 always goes with 5. Don't memorize it like that because I could have called these completely different, right? Labeled them completely different. All right? But this top left one goes with this top left one. You see that? That's the way you really want to look at it. This top right one goes with this top right one down here. Bottom left with bottom left, bottom right with bottom right. That's how you should look at it. Don't just memorize, oh, 1 and 5 go together, 2 and 6 go together. Don't memorize them by the numbers. Memorize by the relationships, how they match up with each other. Do you see how they match up? That's how you want to look at them. That's corresponding angles. Now, what about the white lines? Did I say anything about these white lines being parallel or anything like that? No. Okay, so today, I haven't said anything about these 2 lines being parallel. I meant to finish this today, but I don't think we're going to be able to. But whenever we do the next lesson, 3-2, we will look at these 2 lines and say that they're parallel. And then there's other things that we can say about this. But for right now, I just want you to understand which ones are corresponding angles. Did you write that down in your notes? It's very important that you write that down. Don't just say, well, he puts it on the computer, I'm just going to look at it on YouTube. No, you should have these notes. You should write this stuff down. If you don't, you're not doing enough. Let's do another type. Let's draw basically the same situation. Actually, let's copy them. And copy that. And paste it right there. Okay, same picture. Let's put the numbers in there again. 1, 2, 3, 4, 5, 6, 7, 8. All right, same situation. But I got another type of angle I want to look at. Look at this angle right here. Actually, look at the 2 lines. See this white one here and this white one here? Look at the ones that are between the 2 lines. In between the 2 lines. Which angles are in between the 2 white lines? Which one? 3, 4, 5, and 6. Do you see that? So look, all this stuff right here. Whoops, I went a little bit outside. Let's try to keep it inside. Well, it's close. A little closer. All that stuff right there is what we call the interior of those 2 lines. All right, write that down. Interior. All right, I'm going to get rid of the squiggly. But all the stuff inside of here is in the interior. Justin, you getting all this? Write it down. It's going to help you. Stay awake. Okay, if you're just sitting there just staring off into space, it's going to help you. All the stuff inside the white lines is the interior. All right, let's actually take that word interior and drag it right here. So that's the interior. What do you think all the space outside the 2 white lines are? Exactly. It's the exterior, not outerior. It's the exterior. So you actually have 2 exteriors, don't you? You've got one above the line and one what? Below this one right here. So that's the exterior. Everybody got that? Okay, so that's important to know. So all these angles, 3, 4, 5, and 6. So if I asked you to name all the interior angles, be 3, 4, 5, and 6. If you were to name all the exterior angles, what would they be? 1, 2, 7, and 8. Good. 1, 2, 7, and 8 would be your exterior angles. But we're going to get a little bit more detailed than that. What I want to do is I want to look at angle 3 and angle 6. Do you see how they're on different sides of the interior angle? I'm sorry, of the transversal. Okay? But they're not just on different sides, because 3 and 4 are on different sides, aren't they? 3 is way up here in this group of 4. 6 is way down here in this group of 4. They're complete opposites, aren't they? Do you see that? They're complete opposites. 3 and 6 are completely opposite, but they're all what? Interior, right? We don't call them opposites, though. We call them alternate interior angles. Let's write that down. Alternate interior, and then I'll just put the symbol for angles. Okay? They're alternate interior angles. So, can 1, 2, 7, and 8 be an alternate interior angle? Why not? Because they're what? Because they're exterior angles, right? So the only ones that possibly could be alternate interior angles would be 3, 4, 5, and 6. But when I say alternate, we mean complete opposites. Look at 3. What's the complete opposite with 3? 6 is. Do you see that? So the alternate interior angles would be angle 3 and angle what? 6. Okay, 3 and 6 go together. What's your other pair of alternate interior angles? Angle 4 and angle, oops, that angle's not good, angle 5. So those right there would be alternate interior angles. Again, I'm going to give you something like this. I'm going to say list the alternate interior angles. List the corresponding angles, and you need to know which ones are which. We have about 2 more to do. We'll do that tomorrow. I'll give you a worksheet tomorrow. No homework tonight.